This question asks us to look at a reaction at equilibrium and decide how the reaction responds to the following stresses. So our reaction is 2 moles of silver ion in the aqueous state react with a carbonate ion in the aqueous state to make silver carbonate the solid, and we're told that it is an exothermic reaction. We want to know the effect that different stresses will have on the silver ion concentration. So to summarize this very briefly, any stress that causes the reaction to shift to the left will result in an increase in silver ion concentration. Any stress that causes the reaction to shift to the right will cause a decrease in the silver ion concentration. So for part A, when lithium carbonate is added to the solution, what will happen to the silver ion concentration? If we put lithium carbonate in water, we will get lithium ion, which is not in our reaction, but we will also get carbonate ion, which is in our reaction. So hopefully you think that adding to the reactant side is going to cause my reaction to shift to the right, which will make a silver ion concentration decrease. So we will shift to the right, and the silver ion concentration will decrease. Our next stress is heating the solution. Notice that delta H is negative, so this means it is an exothermic reaction, which means heat belongs on the product side. So if we heat the solution, we are going to increase the heat, which will cause the reaction to respond by shifting to the left because we are increasing the product. That means when we shift to the left, the silver ion concentration will increase. Our next question asks, when silver carbonate is added to the solution, the silver ion concentration will do what? Now, first off, you need to recognize what the scenario is to answer this question. What we have is aqueous silver ion in solution, aqueous carbonate ion in solution, and silver carbonate solid in the bottom of the flask. So we are at equilibrium. Remember that in order to impact equilibrium, materials need to be in the aqueous or gaseous state. So solids do not impact the equilibrium. When I add additional solid silver carbonate to this, I'm just going to add to the layer of silver carbonate in the bottom. Right now, at equilibrium, I am at the maximum amount of silver ion and carbonate ion that can dissolve in solution. So adding more solid is not going to increase that maximum amount. So our answer is the silver ion concentration will not change because the reaction responds not at all. My last question is, when we add sodium chloride to the solution, what will the silver ion do? So hopefully you remember that sodium chloride is Na plus and Cl minus. You may also remember that Cl minus reacts with silver in order to make AgCl solid. So when I add chloride to this solution, what's going to happen is it's going to start reacting with the silver ion to precipitate it and make some silver chloride solid that's in the bottom of the flask. So initially, the silver ion is going to drop, right? Because I've started to precipitate it. Now, if the silver ion concentration drops, which is the stress, the reaction is going to respond by trying to replace the silver ion concentration. So this is like removing reactant And anytime you remove reactant, you shift the equilibrium to the left. So the silver ion concentration is going to respond by increasing after that initial drop in order to replace the silver ion concentration, and that's because the reaction is going to shift to the left. All right, that covers equilibrium.